Question 2. Compute the following limits without using L'Hopital rule. Number 1. What is the limit of a function as x approaches 0 from the left for x divided by x minus absolute value of x? So, for question 2, part A, what is the limit as of x approaches 0 from the left for x over x minus absolute value of x? So answer this. We need to evaluate the absolute value of x. What does it mean? So the absolute value of x equals to the positive x or negative x. And because this function or this question asking for x approaches 0 from the left, so we have to use this part only. This indicates that the x approaches from the left. So the question becomes, what is the limit as x approaches 0 from the left for x divided by x minus negative x, which in turn equals to for x divided by x plus x equals to 2x. So in this case, simply 2. So the answer for this limit equals to 2. Question number 2. What is the limit of square root 3x plus 1 minus square root 7 all over divided by x minus 2? So for this problem, we need to simplify the question first. In order to do that, we can multiply them with its reciprocates. So the reciprocates in this case is simply the same element but the opposite sign. For example, in here the sign here is minus, so the reciprocate will be the positive sign. So everything else the same, square root of 3x plus 1 plus square root 7 divided by square root 3x plus 1 plus square root 7. So in other words, this is equals to 1. So it's alright to multiply by 1, except that this time the sign is opposite. So it was negative and then now it changed to positive. Okay, so what will happen here is, notice here this element, okay, same as this element, whereas on this one, same as that one. What happens is, if we multiply this with its reciprocate, we cancel the square root sign, but we maintain the negative. Okay, so in this case, the numerator become 3x plus 1 only, cancel the square root sign, and then the sign here is minus, and the same thing, we cancel the square root sign, 7. So this comes from the first element, and then this, let me just highlight. So this one is the first element, and then 7 here is the second element. Now we cancel the square root sign, but we maintain the negative sign here. This is come from the formula. I don't know if you remember. If you multiply a minus b multiply by a plus b, this is the same as a square minus b square. So that's this come from this minus sign come from this formula, except that the square root or the square here cancelling the square root sign. So let me just all right, just leave it there, or maybe okay, just leave it there. Continue. So we already removed the square root sign and the denominator is maintained. You have x minus 2 multiplied by everything there, which is 3x plus 1 and plus square root of 7. So everything else the same, except this time you got positive 1 minus 7 is negative 6. So this now becomes 3x minus 6 all over everything else the same. 3x plus 1 plus square root 7, and the numerator can be simplified to 3x minus 2. This will be the same, and we have another x minus 2 in the denominator, all over 3x plus 1 plus square root of 7. So as you can see, we can cancel the x minus 2, leaving behind only 3. 3 all over x, sorry, square root of 3x plus 1 plus square root 7, which this time if we substitute x equals to 1, sorry, x equals to 2, as you can see here the question x approaches 2, we got 3 over square root 3 times 2 plus 1 plus square root 7, or 3 over square root 7 plus square root 7, or everything equals to 3 over 2 times square root 7. Okay. That will be the final answer. For part C, what is the limit of x squared minus 9 over 3 minus x as x approaches 3? So for this part, let me write down for part C. We just write down x approaches 3 for x squared minus 9 all over 3 minus x. So in this case, we simplify the question first. Okay, limit x squared minus 9 is the same as x minus 3 multiplied by x plus 3 all over 3 minus x. So we have a similar element here, 3 minus x with the x minus 3, which we can manipulate if you want, okay, to become negative x negative 3, which is still valid, still 3 minus x overall, see, minus x plus 3, so plus 3 minus x, same thing, except that this time we can cancel the one of the elements. Okay. So we have at the end x plus 3 for x plus 3 all over minus 1 in this case. So in other words, we have minus x minus 3. So if we substitute x equals to 3, x equals to 3, we have minus 3 minus 3. It is equal to minus 6 overall for the answer for part C. Question part D, what is the limit of x plus 5 over square root of x squared plus 1 as x approaches positive infinity? For problem with infinity, limit of at infinity, we can simplify the problem by dividing with the highest power of variable, in this case x. So the highest problem looks like x squared, but x squared at the denominator here is under the square root sign. Therefore, it's actually the same as x, because square root of x squared is simply x. So the highest power here in this case is simply x to the power of 1, or simply x. So we can divide both the numerator and the denominator with, in this case, 1 over x, because we try to cancel the variables. So you can multiply this with 1 over x over 1 over x. So in this case, let us simplify the problem first. So the first one, the numerator x plus 5 multiplied by 1 over x will simply be x over x plus 5 over x, and all over, in this case, square root of, sorry, 1 over x multiplied by square root of x squared plus 1. So in this particular problem, especially on the denominator side, 1 over x here can get inside the square root sign and become x squared also. So in this case, this will become 1 plus 5 over x. Let's cancel that. 5 over x all over, and we want to bring the 1 over x inside the square root sign, so it's become 1 over x squared. We have x squared, this is 1 over x squared. So if 1 over x squared come out of the square root, that become 1 over x. And same thing, we need to do the same thing for the other one, plus 1 over x squared. Moving on, we will have 1 plus 5 over x square root of, in this case, become 1 plus 1 over x squared. Now if we substitute it at x equals to infinity, positive infinity, we have 1 plus 5 over infinity is 0. Let me just maintain everything. 1 plus 1 over infinity square is also 0. So in this case, we have 1 plus 0 all over square root of 1 plus 0. So the answer for this particular problem is 1.